Hello students. Next, let us look at another problem. According to the problem, the network was in steady state when the switch was in position A, which is drawn. And at t is equal to 0, the switch is going from A to B at t is equal to 0. We have to find the expression of voltage V of t for t greater than 0. So as we have done previously, the first thing is before time t is equal to 0, what is the situation? So I will write solution at t is equal to 0 minus, that is just before the switch is going to happen. What is the condition we are having? So the condition is basically that we are having a circuit with only the battery with a resistance, and it is connected to an inductor. Now what about the inductor? See, here it is said that the inductor, the circuit is in steady state. It's in steady state. That means it has already achieved a steady state. That means the inductor is charged. And we know that once the inductor is charged, it will act as a short circuit. And what is the current that is going through it? That is going to be your initial current, initial condition current through the inductor. So what is going to be that? So this is 2 volt, this is 2 ohms. Therefore I naught minus is going to be equal to 2 volt divided by 2 ohms. It's going to be 1 ampere. So this is the initial condition of the inductor, and then the switch is going from position A to position B, and in that case what happens is, as it goes from A to B, what happens is that the circuit at t greater than 0, what is the condition of the circuit? That is first thing that we have to draw. So I will draw that I will have the inductor, but now the inductor is transformed to 2s. And because of this current, there is going to be a an initial current that is going to be, because of this there is going to be a voltage. And what is that voltage? For understanding that, we have to look here. So the voltage will be Li naught with its polarity such that it is in the same polarity with which it has charged. Correct? So based on that, I will draw. So the polarity is like this. So this was plus and this was minus. So going in that way, this should be, let me draw this one. It's okay. It should be, this is minus and this is plus, and it is Li naught. Li naught, L is 2. So I naught is 1. So this is going to be equal to 2 volt. Okay. And then the remaining part of the circuit, so this is connected to B, switch position is now B, this was A, this is B, and that is connected to 1 ohm resistor and an inductor. Now people will ask, sir, should we not draw this inductor to also have a voltage source just like we have drawn here? No. Why no? Because see, when the position of the switch was in A, this inductor was left uncharged. It is not charged. There is no initial current in that particular inductor. And because of that, I will draw this as only the inductor which is having a conversion value of, transform value of S. And whatever is here is going to be your voltage V of S. And we have to find out V of S and we get the answer. So this circuit can be very much simplified and drawn as, these two are in parallel. So I can draw this as very simply as this is 2s This is a voltage source minus plus, and this is 2 volt, and these two are going to be parallel. It's going to be a parallel element, and the voltage is going to be plus minus V of S. So what is this? This is 1 parallel with S. What is 1 parallel with S? 1 parallel with S is going to be 1 inverse, which is 1, plus S inverse, which is 1 by S, the whole inverse, which comes out to be S plus 1 by S, the whole inverse. Therefore, 1 parallel with S is going to be S divided by S plus 1. So instead of writing 1 parallel with S, what I will do is I will write here S divided by S plus 1. And from that, I will get, using KVL, I can directly find out what is the, or I can use the voltage division rule. Voltage division gives us what? Gives us that the Vs value will be whatever is the total voltage, which is 2 volt. So let me write that as 2 volt instead of, so this will come out to be 2 volt, and V of S is at S divided by S plus 1 divided by the total, which is 2S plus S divided by S plus 1, which is going to be 2S. The S plus 1 and S plus 1 will basically cancel off once I do the cross multiplication. Cross multiplication is 2S square plus 2S plus S, which actually comes out to be 2S divided by 2S square plus 3S, from which S can get cancelled. So I will get 2 and 2S plus 3. Now if I want to make my, so this is V of S. This is V of S. Now if I want to make my value such that S is having one coefficient, so I will get V of S dividing by 2. So dividing by 2 means 2 divided by 2 in the numerator, and the denominator 2S divided by 2 will give me S, and then 3 by 2. So this gives me 1 divided by S plus 3 by 2, and taking inverse Laplace transform, we will get V of t is equal to e raised to power minus 3 by 2 t for t greater than 0. Sorry, there is one mistake I made, that is the voltage is exactly opposite, because this is 2 volt is exactly opposite to VFS, so it is minus 2, again here minus 2, minus, minus, this is minus, so this is going to be minus of e raised to power minus 3 by 2 t. So this is a problem. Let's take another problem in which now we are having a capacitor. So the network shown in figure has acquired steady state at t less than 0 with the switch open. The switch is closed at t is equal to 0. Determine V of t. So the solution, as usual, first we will write at t is equal to 0 minus what is happening. At t is equal to 0 minus the switch was open. So what was remaining was, we are having a voltage source which was 4 volt, then we had a resistance which is 2 ohms, we have another resistance which is 2 ohms, and that is parallel to a capacitance. Now if it has achieved steady state, that means the capacitance will be fully charged Once the capacitance is fully charged, it is going to act like an open circuit, and this is the voltage Vc of t at 0 minus, sorry, so I should not write Vc of t, I should write Vc of 0 minus, whatever is the voltage that is going to be. So now have a look here. See, if this is plus minus, it is charged like this, then that same voltage is the voltage that is appearing here, plus minus. So in a way, we need to find out what is the voltage across 2 ohms. And again, by voltage division method, what we are having is Vc of 0 minus is going to be the total voltage, which is 4, multiplied by the resistance across which you want to find out, divided by the total resistance, which is 2 plus 2, which comes out to be 2 volt. Therefore, we have found out this to be equal to 2 volt. Once that is done, next we have to draw what happens when the switch closes. See, when the switch closes, the battery becomes, so at t greater than 0, what happens to the power source? The power source becomes, instead of 4, it becomes 4 by S. Now you might be asking, sir, how it becomes 4 by S? See, it's a switching action. The switch is closed, so at that moment the battery is giving power to this, so that's why it's going to be 4 by S. So once this is known that it is 4 by S, now based on this we can draw the remaining. So the remaining, all the circuit will come together. So we are having 2 ohms parallel with 2 ohms, and now instead of the capacitor we will have not just the capacitor but also how it is charged. And how is it charged? It is charged in the same direction, or the polarity that opposes the original battery, which was, this is going to be plus and this is going to be minus. And what is going to be its value? Its value is its value is going to be V naught by S. So going by that, I will write here, so this is connected, this is going to be 1 by CS, CS is 1, so it is 1 by S. This is going to be V naught by S, which is 2 by S, and this was 2 ohms, this is also 2 ohms, and then here I am having only the capacitor, and now this capacitor has not been charged, so I will just draw it as a capacitor with value 1 by S, and this is the voltage plus minus V of S, which I want to find out. So again, we are in a situation wherein we can solve this using KVL. There will be 3 mesh. You can draw I1, I2, and you can find out using mesh analysis, but 3 mesh. Instead of that, I will go to use the nodal analysis. Why nodal analysis? Because as you can see here, there is only one node here, and one node, this one is straight away 4S, and one node here. So actually you can find out the value of V of S by just doing one equation, or writing one equation. So if this is V of S, then this is going to be your V of S. This node is going to have V of S. Why? Because this element totally has V of S across it. So you need to find only the node voltage. Now let me draw the current. As we have previously done, we can draw the current in any which way, no issue. So when I say this is the node, it means all of this is the node, and this is going to be plus 4 by S. So KCL gives, So first is an incoming current, so it is positive. So 4 by S minus V of S, 4 by S minus V of S divided by 2 minus V of S divided by 2 minus V of S minus 2 by S, V of S minus 2 by S divided by 1 by S minus V of S divided by 1 by S is equal to 0. From which, the let me simplify this. This is going to be 4 by 2S, okay, minus Vs by 2. This is again minus Vs by 2 minus SVS plus 2. 2 by S plus divided by 1 by S is going to give me 2. I suppose you understand that. It is 2 by S divided by 1 by S is basically 2. Okay. So 2 minus S V of S. Why? Because the S goes to the numerator. Is going to be equal to 0. So in a way, this and this will give me 2 by S. So what are the constants? The constants are this one. So let me write the constants here. So 2 by S plus 2 I will make it here. The other all Vs quantities I will take the other side and it will become positive. So it is 1 by 2 plus 1 by 2 plus S, plus S is going to be equal multiplied with V of S, from which I can get it is 2 plus 2S by S is equal to half and half will become 1 plus 2S V of S. Okay. Therefore, V of S is going to be 2 times S plus 1 divided by S into 2S plus 1. If I divide both numerator and denominator by 2, the 2 will cancel off in the numerator, so it will be S plus 1 divided by S. 2 by S divided by 2 is going to be S plus 1 by 2. Correct? So now I have to do the partial fraction. So how do I do the partial fraction? So this is going to be equal to A divided by S plus B divided by S plus 1 by 2. For finding out A, I know the equation. A is equal to S plus 1 divided by S plus 2 at S is equal to 0, which gives me the value 1 by 2. Am I correct? Sorry, this is not 2, this is 1 by 2. This is 1 by 2. This is 1 by 2. So I will get 1 divided by 1 by 2, which comes out to be 2. So A is going to be equal to 2. Now what about B? B is again you get it by S plus 1 divided by S at S is equal to minus 1 by 2. So this is going to be 1 by 2 divided by minus 1 by 2, which comes out to be minus 1. So now I have reached end. So it is V of S is equal to A is 2 divided by S plus B is minus 1. So let me write this as minus. This is going to minus 1 divided by S plus 1 by 2. Taking inverse Laplace transform, V of t is, we know that 2 by S can be written as 2 into 1 by S. If I take its Laplace inverse, I will get 2, and for 1 by S I will get U of t, and this is going to be minus e raised to power minus 1 by 2t u of t. This both u of t means I can write this as v of t is equal to 2 minus e raised to power minus 1 by 2 t for t greater than 0. So that is going to be the answer. So that's how we solve for this case. So as you can see, in both the problems I have taken 2 times. One is just before the uh, initial condition, just before the switching, and the second one is after the switching. Whatever is before the switching, there I am always taking the capacitance whichever has charged as open circuit, or if there is an inductor I will take it as short circuit, and it's all based on time. It's all based on time domain. It is in time domain. Whereas the t greater than 0 part is not in time domain, but it is in frequency domain or S domain. Okay, thank you.